This is a GCSE AQA chemistry question. It's from Trilogy 2019 and it's a higher tier question on the chemical changes topic. Going to recommend that you pause, have a go at the activities for yourselves and then review the answers. So here is part A, part B, part C and part D. So going through the review, whenever there is a plotting question, actually plotting data onto a graph, I'm always going to give the same advice, and that is to do it very, very carefully. Always look carefully at the scale, make sure that you're on the right side of, for example, if it's 320, you're between 300 and 350, not between 300 250. You need to be within a single square of the correct point. Can I also recommend you always do crosses, not dots? Otherwise, they become difficult to see, and if there's no evidence of a plotting point, even with a line there, you might not get the marks. So the points are plotted, and then you're being asked to join the data points with straight lines. So we have got straight line, straight line, straight line, and we're done. On to part B. How does figure 2 show that substance B is a pure substance? And what we're looking at is that it melts at a specific temperature. We know that pure substances have specific temperatures. Adding impurities will change that. And then for part C, determine the melting point of substance B. So this is reading directly from the graph. We go on to here. It's actually 43 degrees. Anywhere up to 45 degrees there would be acceptable. And finally, for part D, we have got the rate of temperature change can be determined from the gradient of the graph. At 120 seconds, the temperature was 173. Determine the rate of temperature change for substance B between 120 and 240 seconds. But the temperature change we just calculated was 43. So to get to 173, there is a difference here of 130. And the time change here is 120 seconds. Gradient is changing y divided by change in x, which is 130 over 120, giving 1.08. You'll see I've done negative 130 there, either acceptable. So 1.08 degrees Celsius per second, or 1.08 or negative 1.08. And that takes us to the end of this question.